Before we do anything, we're going to review the Phishlet format documentation. If you've already worked with Phishlets, you'll notice some changes and upgrades with this version that improve how Evilginx operates. We'll go over the main sections of a Phishlet, like the parameters, proxy hosts, and auth tokens to ensure you know how each part functions. This review is aimed at helping you refine your understanding so you can create more efficient and effective Phishlets. Let's quickly go through the core elements and their purpose. Please pay attention. Let's break down this part of the documentation with clear explanations for each part of the proxy hosts section. Starting with phish sub. Phish sub defines the phishing subdomain. This is the fake subdomain that users will see when they interact with the phishing site. It can either be the same as the original subdomain or something slightly different. For example, if you're trying to mimic login.example.com, you would set phish sub to login. This ensures the phishing domain looks identical to the legitimate one, tricking users into believing they are on the real site. The org sub represents the original subdomain of the legitimate site. This is the subdomain you are proxying traffic from. For example, if the target site is example.com, you would set org sub to www. Evilginx will use this information to know which subdomain to impersonate and pass traffic through to the legitimate site. This is important for ensuring that requests are routed correctly. The domain indicates the base domain of the target website. This is the core domain name of the website you are targeting for phishing. For instance, if you're targeting example.com, the domain parameter would simply be example.com. This helps the Phishlet define which site traffic should be directed to, and it ensures that when users interact with the phishing site, the traffic is proxied through to the real site. Next is session. This Boolean value determines whether session cookies should be captured during the interaction. If the target site uses session cookies to maintain user sessions, you should set this to true. This way, when the user logs in, it will capture those cookies and allow you to reuse the session without needing the user's credentials again. If it's a static site, or if cookies aren't needed, you can safely set this to false. This needs to be evaluated on a case-by-case basis. IsLanding specifies whether this host is the landing host for the phishing attack. When set to true, this means that the phishing link generated will direct victims to this host. This is particularly important when multiple hosts are involved in the attack, but only one is used as the primary phishing entry point. Typically, this will just be the login page. Ending with autofilter, a newer feature, automates the process of creating subfilters for the host. By setting this to true, Evilginx will attempt to automatically filter and rewrite URLs and content as needed without requiring manual subfilter configurations. This is very useful for larger, more complex sites where manual subfilter configuration would be time-consuming and take forever. It also ensures that the phishing site functions a lot more smoothly by automating some of the URL rewriting. These are all the components of proxy hosts, probably the most important part in writing Phishlets. To wrap up proxy hosts, we have first phish sub, org sub, domain, session, isLanding, and autofilter. We will go over the procedure of how to correctly identify these values for just about any website once we get deeper in the course. Make sure to understand these values because it is very important. Missing a one domain or subdomain value will cause your Phishlet to not work and fail before the user even has the chance to enter anything. Next, let's break down the subfilters, keeping a specific focus on how each part applies to creating an effective Phishlet. This may be a little complicated, so bear with me. First is triggers on. Triggers on specifies the original host name for which this filter will be applied. This identifies the target domain's communication that should be dynamically modified by Evilginx. For instance, if you are targeting login.example.com, the subfilter would modify the communication specific to that domain in the response, ensuring that phishing content aligns with the actual target site. Org sub identifies the legitimate subdomain being proxied. It is used to locate strings within the HTML or JavaScript responses of the original website. For example, if you're targeting accounts.google.com, this parameter should be set to that specific subdomain. This ensures that every occurrence of the legitimate subdomain is found and can be replaced by the phishing subdomain. The domain parameter defines the domain name of the legitimate site that will be searched for in the response body. If you're creating a Phishlet for example.com, this helps find every instance of example.com in the response. It's often used together with org sub to identify and replace full URLs or elements that include the base domain and subdomains. Search is one of the most important in subfilters because it uses a regular expression to find strings in the actual response body. This can include URLs, script tags, form actions, or any piece of data you want to manipulate. If you're replacing every instance of login.example.com, you'd create a regular expression to match all URLs and forms related to that domain so you don't lose the proxied session. This allows fine-grained control over what is targeted and changed in the phishing engagement. Replace works in conjunction with search. Once the search regular expression identifies the target string, replace then specifies what it should be substituted with. This is where you input your Evilginx phishing domain that will replace the legitimate content. If your search identifies login.example.com, you could replace it with login.fakeexample.com, thus creating the phishing page. This replacement allows you to mimic the real site, but with attacker-controlled elements that load accurately without fail. MIMES specifies the MIME types that will trigger this subfilter. Basically, a MIME type is a label used to identify a type of data. It is used so software can know how to handle the data. It serves the same purpose on the internet that file extensions do on Microsoft Windows. This is a string array that indicates what type of content the filter should apply to, such as text HTML, application/JavaScript, or applications JSON. Those are the most common you'll see when identifying key values for Evilginx. This is crucial in ensuring that the right content is modified. For example, HTML content might need to be rewritten to change visible links, whereas JavaScript content might need changes to allow phishing logic to execute correctly. Again, like proxy hosts, this needs to be evaluated on a case-by-case basis. The final two parts are completely optional and won't normally be used. Redirect only is another Boolean value that determines whether this filter will only trigger when the user is redirected to the phishing URL. If set to true, it ensures that the subfilter only activates during specific redirects, making it more targeted and efficient. This is useful in situations where you only want to trigger the subfilter during login or credential capture phases, preventing unnecessary filtering during other interactions with the site. Like redirect only with params is an additional conditional filter, meaning that the subfilter will only apply if specific parameters are delivered with the phishing URL. For instance, if certain query parameters are needed to trigger the phishing page correctly, you can define them here to whatever you choose. This adds another layer of control to when the subfilter is applied, ensuring more precision in handling user interactions and the actual phishing flow. This was the purest breakdown of subfilters I could come up with. Hopefully it makes sense. Let's jump to auth tokens, which is where you set up the cookies and session tokens to be captured in the YAML file. Starting with domain. Domain specifies the domain name exactly as it is defined in the set cookie header of the target website. This domain indicates where the session cookies will be captured from. If the domain includes a dot as a prefix, it signals that cookies will be sent and captured for all subdomains of that domain. This is a clear distinction that I see a lot of users fuck up. The dot prefix is important and needs to be paid attention when you are trying to capture authentication tokens from multiple subdomains under the same main domain. Let me say that again. The dot prefix is important when you are trying to capture authentication tokens from multiple subdomains under the same main domain. Think of instances when you're capturing tokens from both login.example.com and mail.example.com under a broader session. The next part in the documentation is keys. Keys identifies the exact names of the cookies that should be searched for and captured. These cookies represent the session tokens or authentication data that are needed to hijack the user's session. You can list multiple keys here if the site uses more than one cookie to authenticate users. For example, common keys might include sessionid or auth token depending on the site. It's essential to know the specific cookie names in order to effectively capture them. Lastly is type and must always be set to cookie for auth tokens. This tells the Phishlet that it is dealing with cookies, as cookies are the mechanism for storing session tokens on the user's browser. By specifying cookie, you're telling Evilginx to focus on capturing session-related cookies, which will enable you to access the victim's session without needing other information. Properly configuring this part ensures that you can capture the right tokens from the user's session to gain access to the account. Key modifiers provide additional functionality for how cookies are handled during session capture. These modifiers are added to the end of a cookie key using a colon and you can stack multiple modifiers by separating them with colons. The first modifier allows you to treat a cookie name as a regular expression. For example, you can match any cookie name that's a specific pattern. This is particularly useful for dynamic keys that change frequently. The second modifier, opt, which marks a cookie as optional. This is helpful for ensuring flexibility in your capture process without disrupting the workflow. Lastly, the always modifier overrides Evilginx's default behavior, which ignores session cookies without expiration times. Adding always ensures that even these cookies are captured, making it essential for cases where such session cookies are needed for authentication. Moving on to credentials, this is the part where the username and password values are captured in Evilginx. These values will almost always be regular expressions, starting with key. Key defines the regular expression to match the name of the field that holds the post data. This value is used to capture specific information, such as usernames or passwords, from the actual post request. Depending on the website's structure, this field can be ignored if the type is set to JSON. For example, if the form is sending the username under a field called user and the password under pass, this field helps identify which to capture. Next is search. Another regular expression, but focuses on the value of the detected post data. If the type is set to post, this will search the specific value of the matched post data, for example, the actual username or password entered. If the type is set to JSON, this expression will search through the entire JSON string. The value captured is based on the first group defined in the regular expression, allowing for precise extraction of the data. The type field defines the content type of the request that will be analyzed. It can be either JSON or post, with post being the default. By setting this, you specify how Evilginx will capture the credentials. If the target site uses a JSON structure in its post requests, set the type to JSON. Otherwise, for most standard web forms, the post type is used to capture the credentials from the submitted form. Now, authentication URLs define a list of URL paths that Evilginx will monitor to determine when a session has been successfully captured. Some sites can require you to add specific auth URLs, and some you don't need to add any. It all depends on the target site and its specific user authentication flow. You'll understand when to add them and when not to add them once you create more Phishlets. So auth URL paths represent authenticated parts of the target website that the user will be redirected to after they've logged in. The goal is to identify these redirects as indicators that the login was actually successful and that session cookies or tokens can be captured. For example, if the user is redirected to /home or /admin after they log in, the session capture will be considered successful, and you'll see this message in your terminal when it happens. These paths should typically point to authenticated areas of the website that only logged in users can access, like a home page or a hello page. For practical application, in the example on screen, auth URLs include /admin and /admin/*. This means that any URL starting with /admin will trigger session capture, such as admin profile or admin settings. Evilginx can recognize these URL patterns as confirmation that the user has been fully authenticated and you captured all the data you needed. When specifying these paths, you can ensure that Evilginx only captures the session when the user has fully completed the login process, avoiding false positives from various non-authenticated requests. This one is simple. Login defines where the login form for the phished website resides. It specifies the exact domain and path that users will be directed to for entering their credentials, which Evilginx will capture. This is a critical part of the Phishlet because it determines where the phishing login page will be displayed and what data will be collected. To find this value, simply navigate to the target website, then click the sign in or sign up button and copy that URL that is showing. The force post section of a Phishlet allows for advanced control over how post requests are handled and modified. Post requests are typically used to send data from a user's browser to the website during login or form submission. Using force post, you can intercept, modify, or replace this data to better capture the information needed for your engagement. Path is a regular expression that matches the URL path of the post request you want to intercept. When a user submits a form, such as a login form, Evilginx will capture and modify the post request based on this matching URL path. This is because you want to target the exact post endpoint that processes the login information. Next, search triggers post arguments. All the post arguments defined in this section must be present in the post request for them to be inserted or replaced. So essentially, this is where you define the conditions under which post arguments will be modified. This is broken down into two parts. Key is the regular expression to match the post argument key, for example, the field name for a username or password. Then the search matches the post argument's value, which is used to match the actual value being submitted, such as the username or password. Force is a list of post arguments that you want to insert or replace in the intercepted post request. You basically can manipulate the data that is sent to the server by modifying both the key and value of the post arguments. This section is broken down into two parts as well, starting with key. Key is the name of the post argument, for example, the field name for the username or password, and value is the value of the post argument, which could be dynamically replaced with another value or modified for your needs. Finally, the type defines the type of post request to handle. Currently, post is the only supported type, meaning this section is dedicated to handling and modifying post requests. This ensures that the Phishlet knows what type of request it's targeting and how to handle it effectively. In this example, we are looking at the block of code at the bottom of the screen, which is designed to ensure that any credentials, specifically the user's email and password, are always submitted via a post request, regardless of any potential redirection. This is for scenarios where an application might try to redirect you to another page using a GET request, which could bypass the proper submission of credentials and mess everything up. Let me explain what this code does specifically. First, the path parameter specifies the endpoint we're targeting, which in this case is the login page at /login. This is the page where users enter their credentials. The search block contains two key value pairs that are crucial for identifying the email and password fields. The first one, user email, is used to search for the email input field. The second key is user password, which similarly searches for the password field in the form. The force block ensures that an additional parameter, remember me, is always submitted along with the form data. In this case, we are forcing the remember me option to always be set to 1, meaning the user will stay logged in. This can be important for certain scenarios where persistence in the session is required. The type parameter specifies that this action will always use a post request, ensuring the credentials are sent properly even if the site attempts to redirect the user using a GET request. This code is making sure that user credentials are always captured and submitted securely through a post request, despite any redirections or changes made by the website. This is a critical function in bypassing an obstacle that could prevent you from intercepting the actual login credentials. This is an overly simplistic example, but you get the point. JavaScript inject, also known as JS inject, allows you to inject custom JavaScript into the phishing pages that Evilginx serves to users. This feature provides significant control over the behavior and appearance of the phished page, letting you manipulate the HTML dynamically or perform more sophisticated and nuanced phishing attacks. Trigger domains define the list of host names on which the JavaScript injection will be triggered. This is because you only want your injected JavaScript to run on specific domains. For instance, you might want to target the login page of a specific site, and this field ensures the injection only happens when the target domain is accessed. Trigger paths is a regular expression that matches all URL paths for which the JavaScript injection will be triggered. By defining these paths, you can further refine the scope of where the JavaScript will be injected. For example, you might only want the script to run on a specific URL within the target domain, such as /login or /hello. Trigger params define the parameters that must be present in the request for the JavaScript injection to be triggered. This is especially useful when using a lure. If the request contains these specific parameters, the JavaScript injection will occur. This adds an additional layer of control, ensuring the JavaScript only runs under precise conditions that are met. Then we have script, which is the JavaScript code itself. This is where the actual JavaScript code that you want to inject is placed. The script is injected just before the closing body tag of the phishing page, allowing you to modify the page dynamically on the fly. You could use this to alter form fields, collect additional data from the user, or execute hidden JavaScript to enhance the effectiveness of the attempt. For instance, you could inject a script to automatically submit a form once the user enters their credentials, or track user interactions for more sophisticated purposes. This is a personal favorite of mine when working with enterprise clients, as you can customize each Phishlet for a specific client.
There are almost endless use cases when using custom JavaScript and Phishlets. We'll dive into many advanced use cases later in the course.
Imagine you're conducting a red team engagement on a financial website that uses client-side JavaScript to apply additional validation to its login form. These validations might include measures designed to detect suspicious activity or prevent unauthorized access. To bypass this, you could inject your own JavaScript code to override the website's validation functions. By doing so, the phish page could capture the user's credentials without triggering the website's client-side security checks. This dynamic approach becomes especially useful when the original JavaScript includes various anti-phishing measures that must be circumvented for the campaign to succeed. In this scenario, the injected script helps neutralize those measures while maintaining the appearance of a legitimate login process. While JS Inject opens the door to customization and control, it demands an understanding of client-side behavior, persistence through trial and error, and the creativity to adapt to challenges in complex environments. In Evilginx, Intercept allows for advanced manipulation and interception of HTTP requests and responses. Each part of this section plays a role in customizing how it will interact with the target's communication. It's broken up into 5 parts. First is domain, which defines the domain name that will be used as the host name in a request. You need to specify the correct domain to ensure that the interception happens on the desired host. For example, if you're targeting a login page or a form submission, this domain field must match that of the host you are attempting to intercept traffic from. Path uses a regular expression to match the URL path of the intercepted request. It's used to pinpoint the exact part of the URL that you want to intercept, such as /login or /auth. When the intercepted request matches the defined path, Evilginx will trigger the manipulation of the request and/or the response. HTTP status is a number value that specifies the HTTP status code that will be returned in the response. For example, returning a 200 status code would indicate a successful request, while a 404 or 500 could be used to simulate a failure or denial of access. Adjusting the HTTP status allows you to craft more realistic or deceptive responses as part of your phishing strategy. HTTP status codes will be reviewed later in the course in full so you understand all the values and generally what they do. Body contains the actual response body to return. By default, it's empty, but you can define a custom response body here, such as HTML or JSON content. This allows you to control what the user sees or what data is transmitted back to their browser after the interception. It's mainly used for mimicking legitimate site behavior or injecting specific content. MIME is the particular MIME type of the response is defined here. This tells the browser what type of content is being returned, with the default being text plain. However, you can adjust this to other MIME types like application, /JSON, or text HTML, depending on the content you're intercepting or returning. This becomes more clear when analyzing the specific login process. Defining the correct MIME type is essential to ensure the content is processed properly by the user's browser. Now, putting these 5 values together in Evilginx allows you to fine-tune how it handles intercepted requests and responses, giving you the ability to manipulate what the user sees and how the server behaves. This is a pretty complex feature that should only be used for very advanced phishing engagements and mainly for programmers who understand Evilginx Phishlet development at the absolute highest level. Here's a practical example of intercept for context. So when the target application sends an OPT via an HTTP request, Intercept captures that request and allows you to extract the OPT in real time. From there, you can automate its submission back to the application, effectively bypassing the MFA step. Intercept lets you match specific requests based on the domain and path, then modify the response with information like status codes, MIME types, and body content. The takeaway here is understanding the HTTP traffic itself, but it's not plug and play. This requires a solid grasp of request headers, payload structures, and response behaviors. Using Intercept is particularly relevant as well for disabling error reporting, altering server-side logs, or modifying responses to achieve specific outcomes for complex situations. While the syntax is relatively straightforward, the effectiveness of Intercept depends on how well you understand the target's traffic patterns and endpoints.